Okay. So what I'm doing right now is I went through, 'cause we added the Mink jet, and I went through and added Mac, or took a look at Mac, Mink, uh, Mock, and sorry, yeah, Mock and Mook, and I went through and I looked at all of the arms that they're using, like grip and slag, that we don't have yet in the cradle for using areas of surf, testing of areas of surf, and I have a little list here of them that I added because Matt's isn't there yet. I'll save it later. Matt's isn't there yet. And I started adding them one by one. So the first one I added was cap, and then I added a jet for cap, and then the one I'm adding now is mass, and I'm trying to add a jet for mass, but mass uses a bunch of uh, functions gates that we already have jets for, like vex and sub and con. So what I'm doing is I am going through and pulling out the common code from jet sub, jet vex, jet con into utility functions that we can reuse. Um, and then adding them slowly into jet mass, which is over here. So the next one, I already did vex and sub. The next one I need to do is con. And another thing, since we last paired together, Phil, was I kind of, so here's, where is it? Somewhere here is the work we did together, and somewhere over here in the branch chain. But then I added them on top of the work I did for the first round of this. So there was a thing where I fixed a minor stack bug and then added the mean stack and the slog hand. Off screen, I went through and I changed the mean stack because we're talking about it. And the way Ed originally suggested doing it was, I think I did a combination. We can take a look at it sometime of what you suggested when we were working on Mink and what Ed originally suggested, where it's stored. The root is stored as like a special thing automatically in the stack, but the stack frames that get added now with the new work by John, it's not a special register in that anymore, or like a special slot. Because originally Ed suggested it have its own special slot um, that every time we did a polarity switch would get like copied, but there wasn't really, like you said, any reason for doing that because not every time that we go down a level into like a knock 9 or whatever, do we actually need a new hint on the mean stack? And additionally, this is like a way that we're using the stack that can also be disabled. Like this, the knock stack itself shouldn't know anything about the mean stack. The mean stack is a usage of the knock stack.
Right.
Do you follow what I'm saying?
Yeah. Yeah. That makes sense to me.
Yeah, and then I went through and I added, oh, I can show you this. We should take a look at this one before I do anything else because I added a more advanced test for the Mink Jet.
WSO. Yeah.
Um, yeah, and then I started doing some more stuff. Like I moved slot. I think this is on the other recording that we noticed that the slot functions were in interpreter.rs. So I moved them out of interpreter.rs into noun because the idea of looking up slots in a cell isn't related to nouns. It's not related to
Yeah.
the
Yeah.
interpreter.
Yeah.
Okay, so let's go back then and look at yes. Whoa. So this is the jet I added here, and the idea is that I wanted the one that we originally did together was the Ming Sap Sap, and that's just a trivial failure. Like it's just there is no trace. It's just the
Right.
root of the trace, which is null. It's an empty list.
Right.
So I wanted to add one that would actually use the spot hints, or I think they're yeah spot hints because of the bar coal.
Right. Yeah.
So I I took this formula here, this knock formula,
Yep.
which is just really simple, but still compiles because it can't be certain, like no min things or anything. And then I had it spit out the knock for it. I cleaned up the knock a little bit because it's not exactly how it gets spit out. Um, for example, if you do this in your dojo yourself, you'll get very long spot hits here. Because what this is, this part right here is like the path that it's
Right.
doing. which I made to be just test. But in the dojo, it would be like slash Zod slash care slash like date, all that stuff. So I made it just be slash test. And this is the spot hint right here as a raw atom, as a number. Oh yeah, I wrote it down here in case. Yeah, and then I go through and I build up this knock formula uh, using the DNT, the direct and cell
Hmm.
helper macros or functions, I guess. They're not macros. Yeah, so I build this up, and the reason it has to be built up in this very peculiar way is because of Rust's borrow checking. So
Yeah.
if you tried to directly, like if I tried to directly take this SS3 S2, I'll explain what that means in a second, and just copy paste it into here where it actually is, oops, down here. If I tried to paste it in there, it wouldn't work because this one is using SAC for this T call function. And it's also using the same SAC, which is the knock stack, in this T call. And because of the two-phase borrow checker, Rust can't determine that by the time this usage is going to be used, this one will have resolved, even though it's
Yeah.
readily apparent. So, and that's in every single place where we make a cell on the stack.
Yes.
Therefore, you have to individually make all of these calls and then finally stitch them all together.
Yeah, you kind of have to put everything in like a normal form if it's allocating anything, which cells are always going to
Exactly.
allocate. D will generally not, so that's why yeah, like on that line you can have multiple calls to D, that's fine, but you can't have multiple calls to T on a line, or at least not nested calls to T. You might be able to do like I mean, there's hardly any time that you would ever actually want it, but like a pair or like you could probably make a list of T's, but you can't
Yes.
put that itself into another T, which is what you generally are going to be doing if you're going to make a list of T's.
Yes. Yeah.
So
So will
yeah,
yes, I should. That's a good clarification to make. It will if it's not borrowing the same reference as part of the inputs. If it's like if this wasn't here, you just got rid of this. This would
right,
work because
right,
it's okay. It resolves it here. It resolves it here. Um, I think this would work. I could see a case where Rust would complain about because oh, it doesn't know which one resolves, but I think Rust doesn't care about determinism to that level. So I think it's fine. But then the fact that it's also here, like this one, I guess always gets marked as first. And so by the time it gets here, it's like, sorry, you're borrowing it again, even though really what it should realize is that you're borrowing it here, that'll get resolved. You're borrowing it here, that'll get resolved. And then you're borrowing it here, that'll get resolved.
yeah. It feels like it should be able to know that um, that somehow like yeah, even though you're borrowing it here, it yeah is resolved, whatever the right word is, by the time you finish that function.
Yeah,
I
so
don't
for that
know
reason,
how to do that, and so I've yeah always done it that same way where it just ends up being a bunch of lines. It's annoying.
they're really, as far as I can tell, there's not another way to do it right now. There's proposals in the Rust community to fix this, but anyone who wants to can read about it here in the Stack Overflow. It's kind of this one is like the root of a bunch of branching out, writing about
Yeah,
the mutable borrow and the two-phase borrow checker problems.
right. What I would wonder, like another option that may work is for cases where like here it's all constants, like it's all constant small atoms. Um, whether you could build a function that's like T but takes nested like arbitrarily nested tuples, and so it'd be one function like T of sac, or it wouldn't be T but like N of
I see.
sac, and it has like possibly nested ones. I don't know if Rust allows that kind of uh like non-discriminated union, but there might be something in that direction that's possible.
I think that would work. This is one of those cases where whenever you run into something annoying like this, there's always like, do I want the uh, X cost of dealing within the annoying way right now, or do I want to solve it once and for all at a cost of like 10x right now?
Right.
And in this case, I was like, I'll just deal with it.
Yeah, which I think is correct. It's good to deal with it a few times before you try to identify what is the best uh, way to compress it. But yeah,
So then this is the trace that it should produce. It should produce our two tone because it's an error, and then the trace is going to be when this gets spit out. If you actually run this knock, when this gets spit out, it'll have faces on it and such, and it'll do helpful things like this will be this is a TAS, right?
you say tap?
TAS, Pat TAS, like
Oh,
the aura is a TAS.
yeah, I think so. Right, and so it'll
Yeah,
recognize that and try to yeah,
yeah. So the pretty printer will recognize that. It's not exactly what it's going to be like when it gets spit out here by Aries, but
right,
this is this is just a confirmation of like if you manually run this knock here, this is what you'll get
yeah,
right here. And this is then, so I recreate this result atom and then I assert the jet and it passed. I would love to show it right now,
nice,
but I'm halfway through a commit.
right. Okay, that's very cool. Um, yeah, I'd be interested to see how the because I never saw any of the stack trace stuff, like how the stack trace stuff gets threaded through the interpreter. Just a little bit.
Sure, sure. So it'd be down here. Yeah. So right now, let me actually, this is one of them. Let me go back up though. So we have kind of three parts to knock 11. There's compute hint. So this is the part where if it's a dynamic hint, first you compute it. And then there's compute result. This is if you had a static hint or you already computed the dynamic hint, um, you go here. And knock 11 done is after that. So you have the opportunity to uh, do something afterwards. Like for example, if you have a memo hint and you haven't seen this in the cache before, the knock 11 done is where it gets added to the uh, cache.
Right.
Right, and you can see here that so in knock 11 compute hint, for example, the one that handles dynamic hints, um, it will add the next thing to do is going to be go to a knock 11 compute result. And then this one here adds that the next thing you're going to want to do is go to a knock 11 done. So it kind of that's how it's doing the stack frames for it. So when you see
Right.
a knock 11 with a dynamic hint, what's going to happen is inside of the two stacks is going to once you get to knock 11, it's going to go on and flip a polarity thing, and the first thing it's going to add is that uh, we're going to do. Oh, sorry, actually, this is no, that's on the different part of the stack. This is a different stack. It's the stack for handling computations, like which instructions to do next. Yeah, so
Oh, right.
basically, yeah, it's going to add compute hint, compute result, compute knock done. So when you as you pop down the stack, you're gonna uh, compute the hint if there is any, or skip over it. If it's static, then compute the result, then do the follow up. And so they have their special functions here, which is match hint pre-hint, match hint pre-knock, and match hint post-knock.
Okay.
So then here is the one I believe we care about. Yeah, so this is the one that has the sham jets in it and the memo hint. So actually, I was mistaken. The one we want is the match hint pre-knock. That's
Okay.
the one that has the slog and it has the hand hunk lose mean spot. All the hints that add stuff to the mean stack. The mean
Okay.
stack is, for those watching, what we call the stack trace stack. It's the one that everything you see when you have an arrow get printed and you have the stack trace, the stack that those stack traces are on with the line information, the file information, that's called the mean stack in vere and Aries. Right.
Yeah.
So here, when we get here and we see one of these hints, we're going to make a new cell with the uh, the tag, in this case, a spot for the test we were just looking at, as the head and the uh, res. I think The rest is the data that's being given to it. I believe that this is going to be the result of the dynamic hint,
That sounds, yeah,
which
I think that's correct.
which yeah, which is going to go through its own null computation, and it's going to get you the file in line
Right.
info.
So often the null computation might be like pretty print the the path that we're at as text or something like that, which
Right.
you don't want to do um, unless you're actually, let's see. So that like that kind of stuff you don't want to actually execute it on. Or right, sorry, this is still pre-knock. So res is that formula before we've evaluated that formula,
Yeah.
and
So
you don't
when
want to
we
run that
finish,
formula unless you actually crash or something like that and need to force the stack trace.
I don't know if that's how it works right now. I think that would be nice. But what happens right now is it gets in match, not in here, but as part of the dynamic hint, like aside from this part where it's going to go for this, it's not going to see spot or anything. But after that, what it's going to do is it's going to compute the
Mm,
result of the knock formula for the dynamic hint, and it's going to pop it back, push it back onto the stack, and that's what res is. So when we get to knock hint, match hint pre-knock in knock 11 compute knock, the result on the stack is going to be either the static hint or the dynamic hint and result of computing the formula, which in our case is going to be the text path. So it's already being computed, and we have it here, and that's what we're adding onto. It's already on the stack. We're just recording that now. It's going to be part of the mean stack.
right.
So this is not just in time computed. We are pre-computing the
I
mean stack
wonder
data.
if I'm trying to remember how this works in vere. I wonder if it puts in like a whole nother layer of like what is computed at this time is, in fact I think it has to is a formula. So
Yeah, I think it has to. So here's the knock. Oh, sorry, knock 10, because the Treewalk interpreter was used before we moved
yeah,
to knock 4,
yeah,
knock 4K. Um, right. So here it is. Haven't looked at this in a while. Haven't tagged formula rest of code. But this is where it adds it. This does a call. Where was it? Ah, here we go. Right, here we go. Means C3 spot. So here's where we handle hunk, lose, mean spot here.
right,
This is in uh, cab and cab hint.
right. And so we say
So this one gets skipped. This one is pushes it onto the stack. Um, and then if nothing happened, then we drop it later from the mean stack.
right,
And the thing that we're pushing, this tack, that has already, whoa, weird highlight. This tack has already been computed. So if we look for um, this, right, return end hint. So this tack was, tack is a cell of Zep Hod, Zep Hod. I think you might know them immediately. I have to keep using these little annotations I put for myself.
mm,
Bus is the subject. Next is the thing to do next. Zep Hod. Uh, where is it? Zep. Yeah, Zep is the tag. Hod is the result of computing uh, the dynamic formula. And
okay,
if it was a simple hint, then Zep is just the tag and Hod is null. But we still do compute the formula here because we do the knock on.
Right. Okay, then yeah, then what I don't know is like, so an example that's worth keeping in mind and maybe testing at some point, I'll paste in the chat here, is this, which maybe that's confusing without the extra spaces, probably. Sorry, without the correct parentheses. Um, maybe that's more helpful as
Here, I'll edit down here so I don't forget.
that might be clearer to I understand how that gets parsed.
This is a slog because Sigbar is going to print it, right?
So Sigbar is like mean hints. Um,
Right. Okay.
and so it won't print in this case because it didn't crash. Um, but if you change the 6 to a zap zap, so this is
It will get
I don't
printed.
know if you have
Okay.
have something there, but yeah, it so this one here, it will print 6 and only 6.
Right.
If you change the 6 to a zap zap, um, like this, then the foo and the foo will get printed as a sigpam, like, so it'll be like a gray printout, and the 5 will be part of the stack trace that gets printed.
Right. So wait a minute. SigPam is just going to add foo to the stack trace.
No, where so
Sorry, SigPam is going to print foo. It's going to slog foo, right?
yeah, yeah. So what
What,
the idea of this example is to see when does the formula for the beginning part of Sigbar, when does that get run? Does that get run always, or does that only get run when you crash? Um, and one way to tell whether a formula gets run is you put a sigpam in it, because that's only gonna slog something if it's actually literally run.
I see.
And
And
so,
I'm going to
yeah.
put the hypothesis that uh, always in both cases, there and uh, varies.
So you would expect it to print out foo and then 6, right? Is what you're
Yeah,
saying.
I think it's going to print out both. So let me throw it in the terminal. Let's see.
Yeah.
Oh no.
But now if you change the 6 to a zap zap,
Oh yeah. All right. So I'm mistaken, but Aries right now it will get run. So how?
so there's a couple ways that this could be implemented, and I'm not sure how it's actually implemented. Um, it could be that it doesn't run the dynamic formula itself, which seems suspicious. Like it seems like that would not be the case, because um, that would be, I think that's a violation of knock. I
Yeah,
think
it has to crash if the hint formula crashes.
um, but what it could be doing is saying that what the dynamic formula produces is itself a formula, and that later on, when when you get what that,
Hmm.
like, if it's just knock one of the thing you were going to do, like of the formula you were going to
Uh-huh.
produce, then it could get run later on. So it's possible that's what it
Right.
does. That's my best guess right now.
Right.
Should be
That
able to,
sounds right. Let's take a look at this.
yeah.
The problem is I don't know um the current interpreter, the bytecode interpreter very well. I only know the tree walking one. Um, but that
Yeah,
sounds
so
like it makes sense.
but
So
yeah,
let's take a look at
we
this
can
hint
look at,
four. Because here they have this hint four instead of n hint. So n hint was what the old tree walking interpreter used. This one has n hint four. Let me double check that quickly. So yeah, they and the n hint hind. So up here we have just n hint. Then as soon as we get out of the old commented out tree walk interpreter, we have n hint four, n hint hind. So there's the four, there's a hind, there's a couple of hinds.
right.
So let me go to uh, hint 4, I guess right here. There's bout. Where's default? Do we have spot anywhere else? Oh, here we go. This is in, where is this? Nbint. Hint processing helper for, yeah, this is what I mean. I really don't know this super well.
I'm pretty sure that somewhere we're gonna end up in U3T something.
U3T is just the push part, though, right? That's in here. I think we're looking for U3T push.
But where we print it out, I think that's also in U3T. I could be wrong.
Oh man. I remember answering this for Jonathan. Now I can't remember.
Let me look in noun trace.
This
Push
pushes to
main.
X. Prompt. Where does this get used? Oh yeah, U3. So we a hella hint will post stuff, so that should use stuff. U3T
Right.
slog trace. U3T slog hella. Yeah, I think U3T slog trace is it.
U3T slog trace. That sounds right.
Sounds right.
Ross Jack tax, flop the order, start to end, render. Yeah, yeah.
Yeah.
Okay, so inside here, what are we doing? We say um right, so we flop it and then we do U3T slog. Okay, so what does U3T slog do?
U3. What is this? Function pointer for slog. Oh, okay, I see. If it has something to slog with, then slog. Otherwise, do nothing.
Okay, do you remember what yeah, where does slog F get set, I guess? What does
I
it
think
get set to?
I can't remember my hotkeys for finding usages. Oh, here we go. I think it did. 0, king slog, and surf slog.
Okay.
In king.c, it gets set to king slog, and in main.c, it gets set to surf send slog.
Okay,
Oh,
let's
actually,
look at
let me
that
double check that.
one.
That one might be
Although
main has a lot of
uh
like helper functions that aren't always. Oh no, that's the
yeah.
yeah. So CW surf commence online uh, online 1165 of CW surf commence. That's where it gets sent to surf send slog.
Right. Okay. Um do we think that the stack trace gets printed on the surf or on the king? If it's generated on the surf, I think it might get printed on the king though.
It gets sent back. The trace gets generated on the surf, and then it is sent to the king as a work whatever, a work plea, a work bail. So
But I don't but like does it
I think it would get printed on the surf, wouldn't it? Like the foo would get printed on the surf, and then the trace would get printed on the king.
maybe? It you could do it either way. I definitely assumed that it got printed on the surf because well, yeah, it kind of has to be because
That's where it's computed.
well but also because the that formula is referencing a large subject that we can't send
Right, right. We're
to
not going to
to
send
the
the
key.
entire
Yeah, yeah.
stack.
Okay, so it
Yeah, that
must
makes
have
sense.
happened at some point before that. That's very weird. That we haven't been able to identify where the trace actually gets printed because it must have because we must have passed it basically. U3T slog trace. Is it possible it was before that? Back in
Let me
like where was the call sites for that? Probably raw Stectra. Uh,
hmm.
U3T slog trace comes from Nara, Hella. Uh, There should have been another one though, right? Like, what about for just like an irregular crash, or maybe that's handled elsewhere, like in
In
the
if
SQL handler or
it's
something?
at least if it's a deterministic crash, I think it is U3 slog trace. Like it gets neatly produced by main can then passed back as a result.
But what's the call site for that? It looks like it's got to be Nara or Hella.
I had this somewhere. Let me quickly pop open this Harry's chat.
Probably Hella because
Or was it
Nara is just the
developers?
one level.
No, it wasn't the John. It was somebody asked about this in Universe or something, and I gave them it there, but I forgot it. All right. So if really is confused. Yeah, into set and hard.
There's a U3 peer sway that mooks the tax. Uh, doesn't get.
I think so. I'm looking at Ncomp. I looked how the slog hint got sent to Ncomp, and I think that in the bytecode interpreter, it does another call to Ncomp when you have a about hint on the formula, and it seems like it compiles it to a formula and more bytecode instructions. And so it seems like what you said is right, that it becomes a set of bytecode instructions to which it'll jump if it detects a failure. But I'm still not exactly sure of the process.
Okay.
Let me just, for the sake of sharing it. Yeah, so in What function is this? An N in cab N cab comp, which is kind of the knock loop, the one with the case 9, case 10, the
Uh-huh.
actual knock named functions. For case 11, it uses nbint, which in the comments it explains is the hint processing helper. And then on line 1088, it calls Ncomp on, you can see it's handling C3 spot. And on line 1088, it does Ncomp of on HOD, which is the formula from the hint.
Right. So we do compile the formula.
So we do compile the formula,
Is it
but it,
possible that somehow we don't run it in the case of, I guess, Bush?
what is Bush? Do you know?
It appears to be the opcode
Or wait,
for saying that we're about to do like,
or sorry, or
do
is
push.
nef, or is nif the dynamic hint formula? It says nef is the. I think I got mistaken. Nef is the dynamic hint formula. Right.
Find out what npep is. Pop and return now.
Wait, so what the heck is nef? Oh, nef is the next formula.
Bush
Right,
really
right. So
looks
HOD,
like
HOD is the formula.
uh okay, because so the way I read this is we're saying call the Bush opcode with the result of compiling the dynamic hint formula at least. Um, Bush gets handled in like do cab Bush.
Do cab Bush. Oops. Bush.
Uh, yeah. Um,
Index product off stack tag is otherwise continue the interval.
what is nrash? Because this overflows into shush. Let's see. Previously the rest of the should know. I think is what that looks like is just like, yeah, pop it off the stack and push it onto the trace, or push it onto, yeah, push it onto the trace with U3T push. So whatever U3T push does,
U3T
which,
push is add to mean stack.
yeah, and that just conses it onto our existing stack. So whatever it got from there, because Ncomp I think does actually, like, it doesn't just generate the bytecode, it expects to run it. There's got to be something special here, and it's probably worth just DMing Paul or Joe about.
Yeah.
Because what doesn't make sense to me, for example, is there's more examples like I'll send you one. This one
1 second.
Compared to this. Like those two I would expect to operate essentially the same, and they do not.
It's gonna be another one in chat. Yeah.
Yeah. Basically, if the formula is being run, then I would expect them both to crash. If the formula is not being run, I would expect neither of them to crash. However,
Mm.
the first one does not crash, and the second one, hangs forever. So I'm not sure what's happening there, and it'd be worth asking them. Yeah, I'm sure we could figure it out by keeping on, digging further, but they can likely point us to it.
Second one gives me a fork error.
Maybe that's not exactly the one that I was running. Yeah, for me it just hangs, but this is like some random fake sod. Oh no, sorry, it does give me a fork error. It's just huge. Okay, so that's a type Okay, that's a type thing. That makes sense. Um, if we do tis less zap zap 3, then I mean it's mint vein. Yeah, okay. So it's hard to get it past the type checker. Um,
Yeah,
but we
but
certainly
the idea
can
stands for the first one.
if we let's see.
No, it's a you want to get past the type checker.
Yeah, I think I know how to do it. Yeah, yeah.
All right, I'll
You
wait
can
for
get
that.
it. Can we get a past type checker with this even? No, it doesn't like that. This is definitely not quite the same thing, and it's actually just much closer to the original assertion. So, uh, okay, so never mind. What these examples demonstrate is that we don't appear to be running that formula. We can't figure out why we're not running that formula. It looks like we can't figure out where we are actually running the formula, and so that would be
Right,
worth asking about.
right. We've yeah, we know that we're not running it. We can't determine exactly how we're making that optimization. We know roughly where it is, but not exactly the process by which we do it.
Right. Right. Something
The,
about pulling it off the stack feels like that needs to be what's running it, but uh, it doesn't seem to be actually doing that. And
so
so,
another way to start is that we're at parity with the old Treewalk interpreter in there, in that we are greedy computing the stack
well,
trace.
I don't think the old tree
Uh,
walking interpreter. I'm nearly positive the old tree walking interpreter did not greedily compute it either. Um,
well, I mean that one the code is a lot easier to follow,
yeah, but
and it seems like it does.
U3M love.
Because it will, where is it? It will call knock on it. So let's see where that is. Retained for debugging purposes. All right, I can't find a definition of knock on. Oh, maybe I can. Yeah, it seems like knock on no longer exists. Just the stub. So we could dive into the history and see what knock on used to do, and maybe it would have some sort of, maybe it would turn it into a formula. Like maybe at the time that the tree walking interpreter was the one that was used, and it used this cab and cab knock cab on function, U3T push and drop were different as well. So
Yeah.
that's, I think for now it might be easier to just, while we ask Paul and Joe about can they point us to where this optimization happens, do they also remember if the tree walking interpreter had an optimization for it as well?
I'm nearly positive that it did, um, which is weird. Or like, yeah, like it's just weird that we're not seeing it. I'm sure. Yeah, very likely they could just point us to it.
So actually I'm going to add a to do in here as well, that to add a XX note that in there, uh, the below formula is optimized to only run / compute the trace on crash, whereas the current implementation is greedy computing it. So even if we're not going to if we're not going to fix that yet, we should have a note that it needs to be fixed. This is a regression.
Right. U3M soft looks like. Uh, wait. Yeah, yeah. U3M soft. I think this actually might be the answer. So in
Turns
now in
off.
manage, um, in vere, yeah,
Oh, and manage.
yeah.
3M soft.
Um, yeah. So soft itself,
There it is.
that one. So the like at the beginning here, we say yeah, soft top, like, and then we seem to be switching on whether we got a good answer. If we got a good answer, we just give that. Um, Otherwise, we if we scroll down some here, we have these two cases where it says don't call mook if we have no kernel, and then evil leaves no trace. So these appear to be handling. So the first one's the unusual case where if we don't have a kernel, we can't evaluate these the stuff that's in a stack trace because we don't have mook. Mook is the function apparently that we use to do that.
Yep.
So it that's maybe worth trying to understand as a simplified case, but the else if and else cases. So else if there are apparently some cases. So I don't know if evil is like non-deterministic or something like that, but there's some cases where we don't where we don't print the type at all. But the else case, sorry, don't print the trace at all. But the else case there, we pass the tax into mook,
Yeah.
and use that. And so,
But
like that,
Mook expects a tang, which I believe it turns into a goof. If that's right.
mook looks like takes a tone and produces a tune.
Sorry, yes. Tone
Rendering stack
takes a
frames, it
tone that it
says.
expects to start with a two.
Right. So in particular, well, basically, yeah. So if it doesn't start with the two, then that means there's nothing to print because it's either a raw value or a block. But if there is a stack trace, then it goes ahead and renders it.
Right.
Okay, so here is where in vere where we actually run the things that got pushed onto the stack frame, which suggests um, that what's getting pushed onto the stack frame. Yeah, okay. I think I see
But spot
how this works.
spot. Well, at least do you see how it worked in the Bear code?
Yeah, basically, I think that um, one second. Let me see if I can
In
generate an
the Boon
example that
code
shows it like more
find.
clearly.
Here. Oh, soft spot. That right.
Here's an example
Yeah.
that's worth pasting into the dojo. And yeah, actually, maybe we can see it in the Luke code as well. I'm not sure, but it's worth
I
pasting that
think I see.
into the dojo to see what's happening. So what this is doing is so first of all what the example does is it like does an assertion that actually wait I think no, sorry, this can be even significantly simpler. I think let me try even uh Yeah, actually, probably it is simpler, I think, to use like this as example.
Do use. Okay.
Yeah, the hexes there are a nice little clue as well, because the hexes are what gets put there if your stack trace itself crashed. Um,
Right.
but yeah, so the way that I read this is knock 11 is saying it's a hint, and so um, the head of that is going to be the clue. It starts with a tag and then has a formula after that. And that formula is a little bit more complicated than I would have expected, but I think a significant amount of that is the Sigbar
It's the
stuff
sig.
itself.
Yeah, the Sigbar is making it a little more complicated.
Right, but mainly that the Sigbar is trying to give you a pretty printer, right? It's saying
Right.
I'm going to pretty print whatever vase you come up with. If you look through that, you can see the 456 456. Like there's a 1 456 456, which is the
Yeah.
thing that we're actually trying to pretty print.
Yeah.
And but what's most important about this formula is that it does not start with 8. It starts with 1.
Why is that important? Eight, I know eight's going to pin a new thing to the subject. One is just going to um, take the subject as is, right?
Right. So what we're required to do by knock is evaluate the clue, specifically evaluate the tail of I forget what exactly gets called the clue and whatnot, but evaluate the dynamic part, right? So 11 has 2 children. The first child is a tag. When it's a dynamic hint, the first child is a tag and a formula,
Hmm.
and so that it has to evaluate that formula.
Hmm.
So that formula starts with 1. It's 1 and then some code.
Right.
It's 1 and then something. And so, how do you evaluate 1 and then something? What is the result of evaluating 1 and then something?
You evaluate the something, and then that's going to give you a index, which you pull out of the. Um, no, wait, no, you just paste it. Sorry, I got confused. One is just raw, right?
Right,
It's just a result.
right. It's just the
Right.
something
So
as a
then it's
literal.
going
You did
to,
not evaluate it.
yeah. So it's going to pass the something as a literal, done, and then move on to the 1 2 3 1 2 3, the
Right,
1 1 2 3 1 2
right,
3.
right. Exactly. But that something happens to be a formula,
Right.
which knock 1 doesn't know about. The hint, like the generic hint logic doesn't know about. And as far as knock is concerned, that formula is just a noun and is never formally evaluated.
Right.
And so then we can choose at any time later to evaluate that by calling mook, or sorry, by
Right.
or like mook is the thing that is going to go and choose to evaluate that. Um, and we can probably see inside of mook where it does that, I would guess.
Yeah, that's what I was trying to do. I went inside of Mook and I realized that yes, because on line 6128, sorry, 6182, for the spot hint in Mook, you can see that the first thing it does, it returns a unit spot, and the first thing it does is call soft spot on data.
Right. So in the case of spot, it looks like it doesn't actually truly evaluate it. It just interprets it as a spot and then runs smite on that to turn it into something. So it's going to run code, smite being the main part of that code. But I mean, well, and also like 6189, there's like string interpolation in there, and like
Right.
that code's going to run at this time on that data. Um, mean is even more generic. The case above that, and Sigbar produces a mean. And with
Right.
that one, we say okay, the data is either a a literal, sorry, like an
Right.
atom, in which case we just do that, or if it's not an atom, then we call Mac.
Yeah, which is just mock, if I remember. It's a wraparound mock.
Yeah, it's some variation on mock.
It's like I think it's a raw mock. Where is it?
Yeah, it's like mock with no scry. It looks like.
Yeah.
Yeah. Um,
Untyped scryless unitary virtualization. Yeah.
yeah. So in the case of mean, we actually run arbitrary knock. In the case of spot, we expect it to have the
To have
structure of
right,
spot, and then we print it the way we expect to print that.
right.
In the case of hand, we are only going to print apparently a mug of it. In the case of lose, we like do I don't know some other stuff. Um, and so like mean, for example, is the only one that can produce those hexes because if you run Mac and it crashes, then it's going to produce the hexes. Say, yeah, okay, um, that couldn't have or like that. There's nothing to print there. Um, okay, that makes sense.
Okay, so
Um,
I'm adding this as a thing. Like we know where everything is. We know how everything is now. I'm adding as a note for myself that after I finish adding all the pieces that Mink, Mock, Mook, and Mac need, and adding in I have some code here where it replaces the current just print in baby.hoon in the baby pill with a hella hint and the Ackerman function.
uh-huh.
So when I get into that part, make sure that I do a version where I also add these these foo prints inside the dynamic formula and see if they get ignored. Like make sure it passes that.
Right, right. Yeah, exactly. And the way that we'd expect that to happen is that uh, wherever we're so because we're producing the stack trace somewhere. At some point, we need to print it out, and wherever we print it out, we shouldn't just try to print the stack trace directly. We should call Mook on it,
Right,
and that's going to give us a tang that we can print out.
right. Which I'm not doing now, so that's something I will have to do. Let
That
me
makes
double check
sense.
that. Because Mook
And I probably
doesn't exist yet.
would explicitly like call out to Mook, which yeah, I don't think we have yet. Um,
Right. No, right now we have just Mink,
right, but
which
also
will
notably,
probably
Mook
rename
is
to Mock.
not jetted, but it probably does call functions that are jetted. So we'll see
Yeah,
when we
like
get there. But what you could also do is implement a Mook that doesn't require any additional jets. That might have more hexes or something. Um, but and then as we add more, like I don't know if there's like if it calls the actual printing printer that might require actually like compiler jets or something. And so once we have those, we can expand Mook to
mhm.
include those. But something like Smite probably doesn't need much of anything, right? And Smite would give you at least the spot traces.
Let me take a look at Smite. I think it's on my list too. Maybe we'll check that. Yeah, Smite's on the list, of course. Pretty print path. Oh yeah.
Yeah,
That's
that
pretty
doesn't need
simple.
any additional jets.
No,
And so that
a
would take
bunch of
like
these
my
don't
time.
need jets. Actually, I think funny enough, I think the only ones that actually need jets are the really core stuff like mass, cap, con.
Right,
Um,
right,
and then Mink itself needs to be jetted by the interpreter, by like the raw Rust code or in C vere code, sorry, in vere C
right.
code. I think everything else on the list is really, well, possibly Scon. Well, no, Scon Skag I don't think have jets, but then yeah, Smite, Soft, Turn,
Right.
Weld, Crip.
Right. Then the one thing that that we would need, I don't know if we have yet, is an Ares function that can print a tank or a tang really, but it's just a list of tanks.
Does Ares need that? Because that gets sent back. We do need that eventually. But I think right now it just gets sent back to King. Like the result is a Tang that gets Newt converted, sent to King, and then King prints it.
Actually, yeah, you're correct. You're correct. Probably would be good to have eventually, but you're right that for this flow it's not needed at all. It just gets sent back to the king. Yeah, yeah, makes sense.
Okay, cool. And I just
Okay.
checked Skag does have a jet, but it is really simple.
Yeah, yeah. Skag probably will want one. You also for you want it at some point, but it may like but for small stack traces. Yeah.
Sure, yeah. I guess so how would you want me to prioritize? Right now I've just kind of been going with the idea of just like build out everything on the goal to this. But I could do it a different way. I could do it like meet the goal first and then start backfilling and stuff to make it more efficient.
So I build out everything on the goal. What's that goal?
The goal is to have stack traces working fully.
Right. Right. Right.
Um, and I've been trying to do it fully, as in like fully, as in the way they work in vere.
Yeah. Yeah.
The alternative is I can add a bunch of skeleton functions that just do what they need to and are unjetted, and then get that working, and then start backfilling jets and parity with vere. Doesn't really matter
Yeah,
to me,
I think
whichever one
it's
you
fine.
prefer.
Either way. I think it's pretty reasonable to be like, yeah, oh, this calls Skag. Okay, I'll just make the Skag jet right now. And if you really wanted, you could also be like, well, okay, Skag is very similar to Slag, and so I'll do that one as well. But I wouldn't go all the way to like, Crypto is also
It's
a
time to
jet,
build a
and
real
so
jet dashboard.
right, right. Yeah, I think it's very reasonable to like to pick up those tasks as you do it. Yeah, that makes sense. And
Uh,
also things like what you were talking about at the beginning of like, oh, I realize as I'm adding these jets that I should be calling the shared function, or like, the sub part of like Bex and so on. Like that kind of refactoring is good to do
right.
as you run into it for sure.
A
Yeah.
good thing. Yeah, I also I bring this up because there's types of programmers, and some are like pure move quickly programmers, and I'm more of the kind where like my natural instinct is to be the blob, like slow and steady, roll forward,
Uh-huh.
getting everything set perfect. So I feel free to like tell me as we have these syncs that like, all right, just like it's okay to move more quickly. We'll come back to this once we get, because that is the plan, right? We want to get
Yeah.
the framework that only a few people can work on at the same time ready, with the goal of like, as we get towards assembly and just after assembly, just like, all right, let's get like 8 engineers filling in all the stuff that the scaffolding is already around.
Yeah. Yeah, exactly. So yeah, there's a balance where, you know, yeah, try not to pull in too big of things when getting something like this done, because if you can get this to the point where, okay, maybe there's some more hexes than it needs or something like that, then it's easy to give someone the job of like, okay, uh, you know, go make it so that there's not so many hexes, or so that the output exactly matches what it was before or something like that. But it's harder to do, like, to assign someone to that if the traces aren't getting all the way to the king in the first place, for example.
Yeah. So I'll try to like, keep that in mind. If I start falling down the rabbit hole of like, do I really need to start pulling out generic Bex code, or like can I just copy paste the Bex code into this other jet, and like later
Right.
when more people are helping, just like, yeah, that's something they see to add a to do, like add a little XX node and move on.
Yeah. Yeah.
For some reason I always
There's
think of
probably
this.
some kind of abstraction on to generate the whole jet Bex function if it's just calling Bex, but I don't know exactly what it is. Well, I don't know for Bex, but like for the binary ones, maybe it's worth it at some point, but it's probably not at this point.
Yeah, it's I'm already doing bad. The first draft that happened off camera was I tried to make it too generic, and I realized like, this the thing I told you yesterday. Like, this is just a jet utility. Just make it work with jets. It doesn't need to
Yeah,
work for any generic U64 code. Just move on.
yeah, that
That was
seems
a
correct.
rabbit hole that I did not fall down for too long, luckily.
That's
But
good.
yeah, I always, for some reason I always picture this as how the railroad got built in the US, like the hell on wheels thing. Where like first the surveyors go through,
Hmm.
then the people that just like level the land go through, then the people that like just dig a ditch go through, then the people that like make a really terrible railroad that's like just good enough for the trains carrying the supplies to roll for, and like the barracks to roll forward.
Right. Yeah.
And then, multiple passes, multiple passes.
Yeah. Exactly. Exactly.
We start with a ditch from coast to coast, and then eventually we'll end up with a railroad.
Right. Yep.
Okay,
Cool.
cool. I think that's a good place to end on for now, for today.
I think so. Yeah. Yeah. I feel like I definitely learned some things there about how stack traces are handled. Cool.
And I finally got to drive,
Yeah.
or I finally chose to drive. I shouldn't say got to. I usually don't want to.
Yeah. All right. All right. Then I'll end the recording now.